So far, we have studied reflection of light, that is, change in the path of light in a given medium. We have now to investigate what happens the light goes from one transparent medium to another. Does it move along the same straight line or changes its direction? Let us recall some of our day-to-day observations with the help of which we can explain the refraction of light. Many times you have observed that a pencil partially immersed in water appears to be bent at the interface of air and water, or a coin kept in water in a glass, when viewed from the side, appears to be bigger than its actual size, or when a thick glass slab is placed over a printed page, the letters appears to raised when viewed through the glass slab. Let us see how we account for these observations. These observations are related to the phenomena refraction of light. Hence, we can define refraction of light, the phenomena of change in the path of light in going from one transparent medium to another is called refraction of light. It is the phenomena of bending of light from its original path for entering another medium. The refraction occurs right at the boundaries of two media, where two surfaces are separating. At the boundary line, the refraction takes place. In the examples, you have seen that a ray traveling obliquely from one transparent medium to another, the direction of propagation of light changes. That is, the straight line path of ray in second medium is different from the straight line path in the first medium. It means the ray turns or bends from its original path on entering into the another medium. Transparent substance in which light can travel is called an optical medium. The optical medium may be air, water, alcohol, or glass. Different optical media have different optical density. Speed of light in different optical media is different. A medium in which speed of light is more is called optically rarer medium, and in which the speed of light is less is called optically denser medium. Light travel faster in optically rarer medium and light travels slower in optically denser medium. So, any particular medium is not denser or is not rarer. The comparison will tell us which medium is denser and which one is rarer. Suppose you are comparing water and air. Here we can say that air will be treated as the rarer medium and water is denser medium as compared to air. Then again we compare the water and the glass. Here water will be treated as rarer medium and glass will be treated as denser medium. Hence we can say that the light can travel faster in optically rarer medium and slower in optically denser medium. Now see with the help of an example. Here in the picture I have compared three media. The first one is air, and the yellow light is showing you the faster movement of the air. Then second one is the ray is traveling from air to water and its extent is reduced as compared to air. And the third medium is the ray is traveling from air to glass and the yellow line becomes shorter. This shows the speed of light is less in glass as compared to water and is less in water as compared to air. Dear students, as we know that speed of light in air is a constant and that is 3 into 10 raised to power 8 meter per second, and speed of light in water is 2.25 into 10 raised to power 8 meter per second, and the speed of light in glass is 2 into 10 raised to power 8 meter per second. Therefore, air is an optically rarer medium compared to both water and glass. On the same basis, water is optically denser than air but optically rarer than glass, and glass is optically denser than both the air and water. We will also define the rarer and denser media on the basis of refractive index in our next lecture. After having the knowledge that speed of light is different in different media, you have observed that speed of light is maximum in air as compared to water and is more in water as compared to glass. Now see practically what happens when light travels from a denser medium to a rarer medium. In the second picture, the light is traveling from a denser to a rarer medium. At the interface boundary, you are observing that a bend is there and the light is bending from its original path. This bending shows that the speed of light is increasing in that media, and to maintain its speed, the light has to bend more, and that bends away from the normal. In the first figure, it is shown to you that light is traveling from a rarer medium to a denser medium. Again, at the boundary, at the interface of two media, a sharp bend is shown to you people, that again the light is bending from its original path, and this bending is slower. The speed in denser medium decreases and the light is bending towards the normal. From these observations, you can say that speed of light decreases in denser medium and increases in the rarer medium. We want to know to how much extent the refraction takes place. The change in the direction suffered by a ray of light as it passes obliquely from one medium to another, is known as the refraction of light. The bending is shown at the surface up to where the water is filled in the tumbler. The interface, which is separating the water and the air, is acting as a refraction point. Here the arrow shows you the refraction point. At this point the light is bending, but look carefully that some part of the light is reflected back. Now you can say during the propagation of light from one medium to another, the maximum of light refract, but a very small part of light is reflected back also. Refraction can make an object appear to be in different position. At the point of arrow, you can see that outside water the pencil is straight, and near the interface the pencil appears bent. For the same reason, the part of pencil which is submerged look as if it has moved away from the part above water, and it appears fatter as compared to the portion which is outside the water. In the same way, we can observe that when a thick glass slab is placed on a printed paper, the letters are highly raised as compared to when a thin transparent medium is placed on the printed paper, the letters are not so much raised. These observations indicate that light does not travel in the same direction in all media. Here the question arises, what is the cause of refraction? The basic cause of refraction is the change in the speed of light in going from one medium to other. For example, when a ray of light traveling in air enters into glass, the speed of light decreases. Therefore, bending of light or refraction of light occurs at the interface of air and glass. Similarly, when a ray of light traveling in a glass enters into air, the speed of light increases. I have told you. Therefore, the bending of light or refraction of light occurs at the interface of glass and air. Further, the angle of bending of ray would depend upon the difference in the speed of light in two media. Larger the difference in speed of light, greater will be the angle of bending, and vice versa. For example, light will bend through larger angle in going from air to glass than in going from air to water. This is because the speed of light in air is, that is 3 into 10 raised to power 8 meter per second, and in glass is 2 into 10 raised to power 8 meter per second, whereas speed of light in water is 2.25 into 10 raised to power 8 meter per second. In this way, you can say only cause of refraction is the change in the speed of light when it is traveling from one medium to another. Let us see what is the change in the bending of light. Here, this picture is shown to you. In this picture, I have labeled various parameters. Here, the glass slab indicating denser medium, the white portion indicating the rarer medium, the red color normal is the normal to the surface, and IO is the incident ray which is falling on the surface at point O. This O point is the interface point. I is the angle of incidence. The angle of incidence is the angle made by the incident ray with the normal. Then OR is the refracted ray and R is the angle of refraction. What is angle of refraction? The angle of refraction is the angle made by the refracted ray with the normal. And you can see in this picture that the ray is bending from its original path and its bend is towards the normal. In case of reflection, angle of reflection was equal to the angle of incidence. This was the law of reflection. But in case of refraction, angle of refraction is never equal to the angle of incidence. One may be smaller than the other or larger than the other. Here, the angle of refraction is smaller than the angle of incidence, indicating that the ray bends towards normal in going from medium 1 to medium 2. In the previous slide, you have observed the bending extent of light, how it is bending. Now here you can see that the light is traveling from a denser medium to a rarer medium. Here IO is the incident light, I is the angle of incidence, and OR is representing you the reflected light. Here R is the angle of refraction. This dotted line is showing you the original path of the incident ray, but it is bending because it is moving in the rarer medium, and in the rarer medium the speed of light increases. Due to that increase, the angle of refraction increases. I have told you that never angle I and angle R equal in refraction of light. And in the second picture, you are observing that angle R is less than angle I. So you can say when rays traveling from denser to rarer medium, the angle of refraction is more as compared to angle of incidence. And if light is moving from rarer to denser medium, then the angle of refraction is less as compared to the angle of incidence. In the third figure, what is shown to you that the light is traveling normally. And if the light is traveling normally, what happens? Then the angle of incidence is equal to 0 as well as the angle of refraction is 0. This violates two conditions. First, that the angle I should never be equal to angle R. So this is not the situation of refraction. Hence, this is the condition of no refraction. When there is a normal incidence, then there is no refraction. One more situation is there when there is no refraction, when the two media are having same refractive index. In that situation, there will be no bending of light. If the light is not bending, then that there is no refraction. In that situation also, you can say the refraction is not taking place. Now this was all about the refraction of light. In the next lecture, we will study about the refractive index, which is related with the refraction of light. For any query, you can call.